Hey there, chemistry. This is Miss Ruark. This is Vodcast 3.1, where we're going to start talking about bonding and how the atoms bond, or how the elements bond together, and what kind of bonds they make, and then we can really start getting into this chemistry stuff. Alright, so looking at your Vodcast notes, you have something that looks like this, and we're going to go through and fill in a handful of these, but not all of them. I'm going to actually have you guys fill in the rest of them, because you should know how to do this by now. You just need me to show you what all this means, because you're probably looking at it going, I don't know what it means, and that's okay. Alright, so let's look at chlorine. Chlorine, the atomic symbol, or the element symbol, would be Cl. The total number of electrons for chlorine, remember that's the number of protons, would be 17, because it's an atom, not an ion. How many valence electrons does it have? Well, it's in group 7, or 17, so it has 7 valence electrons. And if it was to lose or gain electrons so that it would be like those noble gases that it's next to, it would only need to gain 1 electron. So it would gain 1 electron, and therefore if it took on 1 electron, it would have an oxidation number, or a charge, of a -1. Oh, that's what you mean. We went through that ion POGL together, and it showed you how to look at the periodic table to determine the charges. Well, we'll do some more practice with this so that it becomes second nature. Okay, let's look at potassium. Potassium is K. Its total number of electrons would be 19. The number of valence electrons would be 1. Now, would it be easier for potassium to gain a whole lot of electrons to be like krypton, or to get rid of that 1 electron to be like argon? Well, remember that atoms are lazy just like we are, so it's going to do whatever requires the least amount of work. So it's going to lose 1 electron. And how do we know how many electrons it loses? Well, it wants to lose all of its valence. So it's going to lose 1 electron, and it's going to end up with a +1 charge. Alright, so I think you're getting the hang of it here. Let's look at aluminum. Aluminum would be Al. Aluminum has 13 total electrons, and it has 3 valence electrons. How do we know? By the group number. Okay, is it going to be easier to lose 3, or is it going to be easier to gain? It would have to gain 5 in order to be just like argon. Well, it would be easier to lose 3 electrons. So if it lost 3 electrons, it would have a +3 charge. Alright, I think you're getting the hang of this. I'm going to do one more with you. Okay, carbon. Carbon is C. Carbon has 6 electrons total. It has a total of 4 valence electrons because it's in group 14. Now, is it going to lose 4 electrons, or is it going to gain 4 electrons? And you're like, well, 4 and 4, it's the same amount of work. That's right, it is the same amount of work. But carbon's a nonmetal, so we're going to say that it loses 4 electrons. Yes, loses 4 electrons, which means it's going to end up with a, sorry, I did that wrong. That's why you're going, what? It's not going to lose 4. That's right, it's going to gain 4, because nonmetals gain, don't they? Silly Miss Ruark. Alright, they take. They're nasty little boogers. They like to take everything out of the way from other people, so it's going to make a -4 charge. Alright, what I want you to do is finish the rest of these. That'll give you some extra practice, and we'll check them when you come to class. Alright, so let's get into this bonding stuff. An atom that gains 1 or more electrons will have a negative charge. That's important because it's gaining negative entities, or negative particles. And an atom that loses 1 or more electrons will have a positive charge. Okay, this is all review. We've all done this before. We're just reviewing it again. An atom that gains or loses 1 or more electrons is called an ion. And then a positive ion is something that we call a cation. And if you don't remember, it's when Ms. Ruark said cats have paws and they're positively perfect. Yes, now you remember. Okay, and then a negative ion is called an anion. All right. Forming ionic compounds. So an ionic compound is a bond that forms when electrons are transferred from one another. Okay, transferred from one another, and that's how they form those ions. Look, it says ionic, ions, meaning you have to have charges. Charges are key. All right, bonds represent the attraction, the bond represents the attraction of a positively charged particle and a negatively charged particle, or the closeness. Each atom is left with a full outer shell, or a full valence electron shell, or energy level. And an ionic bond forms between a metal ion with a positive charge and a non-metal ion with a negative charge. Remember, if I'm going too fast, feel free to stop and pause and rewind and watch again. Okay, so I'm going to let's do the first 4, and that way, oh, that was horrible. Okay, try that again some other time. And you can do the last 2 on your own to see how you do with this. So sodium is going to be Na, and Na is in group 1, which means it has to have a positive 1 charge. Well, chlorine is Cl, and it's in group 17, which means it has to make a negative 1 charge. And if you're unsure of that, then we'll go through it in class. Okay? All right, so we've got 1 Na and 1 Cl, and guess what? They're going to come together to form Na and Cl. Okay, cool. All right, magnesium and iodine. Magnesium makes a positive 2 charge and iodine makes a negative 1 charge. They're going to come together. We want our overall charge on these compounds to be 0. And so in order to cancel out this positive 2 charge, I need 2 iodines, which means I'm going to end up with MgI2. It's okay if you don't get it yet because we're going to get you there. All right, potassium is in group 1, so it has a positive 1 charge. Iodine is group 17. It has a negative 1 charge. We put those together. We need a 1-to-1 ratio because there's a 1-to-1 charge, and so we would end up with Ki. And then sodium is Na with a positive 1 charge because it's in group 1, and oxygen is O with a negative 2 because it's in group 16. And we need 2 sodiums to cancel out 1 oxygen, so we would end up with Na2O. And go ahead and try 5 and 6 and see how you do with them, and we'll check them when you come to class. All right, so how are ionic compounds organized? Well, they're organized very neat, very structured, and very orderly. You can have different types of structures here. You have your cesium chloride, where you have... Do I have them labeled? No, of course not. You have your cesium chloride, which has the 1 cesium metal atom on the inside, and then all of the other nonmetals are structured around. I believe this is cubic center face, but I cannot remember. And then you have your nice and neat, where you have 1 chlorine and 1 sodium, and I don't remember what they're all called. But I'll remember by the time we get to class. Okay, but these are different ways that the atoms can be rearranged, and that's why you get these nice, pretty crystallized structured in your ionic compounds. Okay, so properties of ionic compounds. They're typically going to be solids at room temperature. They're going to have extremely high melting points, which are going to be about 300 degrees Celsius or higher. They are good conductors. Ooh, that's not good. Good conductors of electricity. When melted or dissolved in water. They are highly dissolvable or highly soluble. Dissolvable. I don't know if that's a word. I think I just made it up. Or highly soluble in water. The ions arranged in regular repeating patterns called a crystalline structure. And it's made of something that we call formula units, and it's not true molecules. And we say it's formula units because we can have a never-ending repeating pattern of formula units or these ions coming together. In a molecule, though, you have a set number of metals, nonmetals, whatever it is that's attaching. All right, a covalent compound or a molecular compound is formed by the sharing of electrons. Atoms can form single, double, or even triple bonds to satisfy what we call the octet rule for each atom except for hydrogen, because hydrogen can only hold 2 electrons. It can't have 8. All right, properties of covalent compounds. These can be solids, liquids, or gases. They tend to have low melting points and low boiling points. They don't always dissolve in water, and they are poor conductors of electricity. We call them insulators. All right, metallic bonding metals have closely packed cations with a sea of valence electrons freely moving around them. Metallic bonds form due to the blank of free-floating valence electrons positively charged. I don't remember what goes here. Metallic bonds form due to the... I don't know what goes there. I can't remember. I'm so sorry. But these come together, and there's these free-floating valence electrons that are floating around. They go from positive ion to positive ion, and that's what allows that. Current to go through. All right. So here are some different metals that you can see. You have your chromium metal, which is going to be body-centered cubic. Then you have your gold, which is face-centered cubic. And then you have your zinc, which would be hexagonal closed packed. And this just shows some of the ways that your crystals from metals can be formed. All right, properties of metals. They are excellent conductors of heat and electricity. They are ductile, which means they can be drawn into wires. They are malleable, which means that you can pound them into thin, flat sheets. And they are crystal. Their pattern is crystal. All right, determine the type of compound. So a metal and a nonmetal will form an ionic compound. So if you see a metal listed first, it's an ionic compound. If it's nonmetals only, nonmetal, those form covalent compounds. And if it's just metals, then those are metallic compounds or metallic bonds. All right, so for example, here we have KNO3. K is a metal, so this would be an ionic compound. Fe2O3, Fe is a metal, so this would be an ionic compound. C for covalent. Haha, no, C for carbon. But C is a nonmetal, and it is a covalent compound. N for nitrogen is a nonmetal, so it's a covalent compound. Cu is metal, so it's ionic. C is a nonmetal, so it's covalent. C is a nonmetal, so it's covalent. And bronze is actually called an alloy. We could say this was a metallic bond because it would have all metals in it if you wanted to. All right, I think that's it. All right, so I will see you in class.